Okay, so if you check the link from that I sent to you on the Canvas announcement, you will find lots of files. So let's try to lay out what these files have. Just like pay attention because this is very important information. So you will find a folder called courseproject.pdf. So for this one, if you download, you will find what task is exactly that you are required to be done as a part of this project. And they are mainly 4 tasks. So, but before you start these tasks, I need you to know that the submission will be in the form of like you are writing an ASCE journal paper. Like it's just like you are not gonna write like a normal like Word file. So I will give you like a template. Let me show you. Do you guys know the ASCE journal? Okay, so you will have the paper will be, okay, let me open a publication so that you can see. So here, hurricane paper, publish. So it's a really simple format. You will have the header for your project. Maybe you can write flood risk assessment for Lumberton, North Carolina. So or maybe you have whatever headers that work for you for your project. Basically, we are doing flood risk assessment. We are doing case study. So you combine all these keywords together and make up a header for your project. And then you put your name, your Panther ID, and then an abstract about what are you going to do. Like I'm going to do flood risk assessment, flood vulnerability assessment. We did this, we used fragility-based functions, we developed high-resolution hazard models, we did like multi-return buried analysis, we did loss assessment. So you describe what exactly that you do, because the abstract, it summarizes the novelty of the work that you are doing. So this is the very thing. And then you will have an introduction. So this introduction, basically, I want you to read some papers. I assigned already some publications for you for reading that help you to generate something for the introduction, what maybe you will go through. We have 1 month right now. I'm not gonna assign any homeworks anymore. So we have the whole month of April to do this. And every lecture, I'm gonna guide you step by step how to get done with each part. So you will need to start now. And my recommendation is that you start to build this Word file first, because you need to keep working on getting results. And the same time you want to have like the body of the paper or the body of the project description is ready. So once you get to have results, you just put it in the paper, but you already have the abstract done, the introduction done, maybe part of the methodology done. And to be honest, you can publish this paper once we are done if you want. I did this with one of my class projects. Like he asked us to develop the course project in a paper format. So we made it in a paper format. And once we have done a year later, I was like, I got communicated with the journals. I need simple publications, and I submitted and I get published. So you can do the same if you want. Maybe you all can combine all what you are doing and submit a paper together. So this is just kind of idea. So, and also at the same time, I'm training you how writing a paper will look like. So it will be just like, you will have to build a paper like this. And I believe I have a template ready that you will just fill it out. So you don't have to redesign. And I did it the same with the class from previous semester. Project. I'll search for the template. I believe it's somewhere in my folders. And you will basically just fill the, like you will find the abstract and you just fill text, and you find introduction and then fill text. So it will be like not that big deal. I believe maybe it's on Canvas, just like to, let's go check on Canvas very quick so that you have an idea how it will look like.
How many pages?
It doesn't matter the number of pages, just like as sufficient. Project. Okay, here's the template. Let's check it. Yeah, it will be something like this, but you are doing your project on your own. So you'll put the name and then you'll have an abstract, keywords, and you'll have introduction, methodology, and then you'll just fill some sections, okay? Does anybody have any questions? Is that clear? Okay. Let's get back. So this is, here. Okay, so you write an abstract and the introduction, basically, the body of any paper introduction, you just go through the literature and see what other people have done in this field, what vulnerability functions that has been used over the years. There have been multiple methods that has been developed for flood vulnerabilities. There's stage damage functions, there is fragility functions, there is like there are many ways. So you just like go navigate. I have a review paper. You can also check it. I'm gonna add it to the reading list. And then you start to build the body of the introduction. And in the last paragraph of the introduction, you say, what are you going to do? Like you'll say that these are the gaps in the literature. These are the gaps that the people have done. Like, for example, most of the papers, when you read them, the introduction should summarize what other people has done and what gaps that is there and what are you going to do. So for example, like you will say the gaps is that most of the method that has been in the literature is deterministic method with less probabilistic methods. And we are going to use a probabilistic method that is based on the fragility. And you will say that, for example, Lumberton, there are not many models that are based on return period. So I'm going to develop a hazard model based on 200-year return period. So you basically list what is not there and what is you are going to do, as simple as you can. Okay, so this is for the introduction. Then the methodology. So in the methodology, usually when you write a paper, if you mix between the application of your method and the fundamental of the method itself, the reviewer will come back to you and will tell you, okay, this is an application paper. This is not, doesn't contribute to the fundamental knowledge of the science because you only done an application. I can't separate between what you already actually developed and what is the application that you have. So usually if we have an example that we are going to apply our work at, we make our methods general. Doesn't mention anything that is going to be applied to any case study. So we will say that we have a flood vulnerability functions that are generally and can be applied for any community. And we have an approach to develop a hazard map, but we doesn't mention that we already developed the hazard map for Lumberton or any case study. Because when you've done this, because usually when we publish papers, we don't want the reviewers to ask us to submit the paper as a case study because case study is at the tail of the publishing credits because you want to have a methodology paper more than a case study paper. Methodology paper is that you contributed to the knowledge and the fundamentals of the science, but case study paper is just an application. So it doesn't say that you already contributed to the science. So that's what we want to do. So what we are going to do is we are going to write a general methodology. This is how we develop the hazard. We develop the hydrodynamic models that capture the spatial distribution of the hazard across the community. And this model, HICRAS, is based on finite volumes. So basically, HICRAS solved the shallow water equation. It's called Saint-Venant equation. If you did a little bit of a dig to know what HICRAS is doing, he solved an equation like, for example, if you are having a slab and has a load, and you use SAP or ETAPS to solve this, basically, we are solving the plates equation using finite element. Same thing with what we do in HICRAS. We are solving shallow water equation to get the water flow using finite volume, same thing. So you'll describe what HICRAS is doing, and this is for the hazard. Then for the vulnerability, we have detailed building data, or our model use detailed building data such as the number of stories, foundation type, construction material, vertical floor elevation to build a high resolution model of the community, and blah, blah, blah. And then we did that, and we did this to build a high resolution community model. Vulnerability, most of the models in the literature are using stage damage function. So we are using a portfolio of flood vulnerability function that are based on fragilities. So this is what we list in the method. So you'll have to list everything about what your method is doing. You'll have to put maybe some pictures of the archetypes that we use to model the community, maybe about the fragilities that you have used, because these are general. Then after the methodology, you will list that you are going to apply the method that you developed to a case study. So right now, that's what we did. We tell the journal, or we are telling the people that we have developed a viable method that can be applied to any community. And I explain the method. And the next step is I'm going to apply this method to a real case study. Then you put a case study that we are going to apply this to Lumberton, North Carolina. And Lumberton has a 20,000 building. It's have a disadvantaged population. It has these numbers of buildings. It has this number of people, or the race, how many races are there, and what is the percentage. That's what we do in most of the papers. And then we get to results. When we applied our methods to Lumberton, we found that these are the amount of losses that this building has, with some color-coded buildings based on their loss percentage, based on their damage, and all this stuff. And finally, once you list your results, you will have a last section for the summary and conclusion. So what is good about your approach? What is not good about your approach? What is the limitation of the approach? What can be done as a future studies, and all this stuff. Is that clear? Did any of you have write a paper or published a journal paper before? So you know how's the process look like. So it's like the same as I'm telling you, like abstract, introduction, methodology, case study. If you have an application, some paper doesn't have a case study. It's just a method and that's it. So because there is no room to have a case study. So, and sometimes reviewer, okay, we know the method, so how we can apply this paper. Sometimes people publish a methodology paper and have another companion paper for the application. So there's a method and there's an application. Okay, so this is for the body of the project report. We will be using ASCE, and I'm going to upload the template so that you can use it. Okay, let's get back here. So this is the first thing, and this is what I'm trying to say here, that the project submission needs to be in the format of ASCE journal. Task 1 is the hazard and exposure modeling using HICRAS. Okay, so I would like you to use the flood hazard model developed from homework 5. So you guys developed the hazard model from homework 5, right? I want you to put it here, but what I'm gonna do, I'm gonna give you what is the exact hazard map that each one of you should get. If we did the model by the book, like if we add the land cover, if we add Manning coefficients based on everything, I'm gonna send it to you so that we can have a realistic loss analysis result. Is that okay? So you will put your hazard map, but also you are gonna use the map that I'm gonna send to you for the rest of the analysis. Okay. So in the Google Drive that I shared with you here, you will find a folder that has the name of each one of you. Okay, so like, for example, Edward will have a 25 years hazard return period. Omar will have 1,000 year. Muhammad will have a 500 year. Everyone will download the map that I assigned to you. And if you open this folder, for example, let's open this one. So you will find one hazard map. It's the water surface elevation. I didn't give you the depth hazard map. What is the difference between the depth and the water surface elevation? Okay, because the shapefile of the buildings that I give to you, it will have the ground elevation and the vertical floor elevation. So you will have both. So you will use the water surface elevation to get the flood depths measured from the ground elevation and measured from the water surface elevation. Okay, so all of these numbers will be like 100. I'm not sure. I believe this one is in meter, just like double check also because the units may be an issue. This map, if the numbers in this map are like around 119 or something, or 120, so that means they are in feet. Okay, I'm gonna double check this. Let me see here. I just generated them. Okay. Yeah, I believe the water surface elevation is in meter, that all the maps that I sent you in meter, but I'm not sure somehow some of you, when they got these maps into HICRAS or in GIS, they found it is in feet, like it has hundreds. So right now, can you see the number here? It's like 36. If you multiply it by 3, it will give you around this number, which means that this number is in meter, but this number is in feet. So double check, okay? Because the shapefile that is in the Google Drive, I believe they give the ground elevation and the vertical floor elevation in feet. So let me also double check flooded building points. So you will have FFE here, this numbers. What is the units of these numbers? It's in feet because it has hundreds, okay? So this numbers is in feet. The ground elevation, I'm not sure if it's here, but you can, I can send you the digital elevation map and extract the ground elevation from the digital elevation map. So you can get what is the ground elevation at each one of these buildings. But this number is very important, okay? So what I'm gonna do, I'm gonna add digital elevation map, or you already guys have the digital elevation map. You used it already for HICRAS, right? So what you are gonna do is, you are gonna add the digital elevation map that that you guys used for HICRAS here. I believe it's somewhere here. Green. The map name has 2014 NCFBM, so you will just drag it and drop it into your model, and then you do the normal extraction that we are used to, because this is the digital elevation map or the ground elevations. And you extract the value of the ground level at each building. Do you guys know how to do that? Extract multi-values to point, and you get the ground elevation. So right now you'll have the vertical elevation, the ground elevation, and also the water surface elevation from the map that I sent to you. So you will do the same thing. You will take the map that I sent to you for the water surface elevation, drop it, and extract the water surface elevation at each building. Then you will calculate the flood depths measured from the ground elevation, and also the flood depths measured from the vertical floor elevation. How? This one is the water surface elevation minus the ground elevation. This one is the water surface elevation minus the vertical floor elevation. Ground elevation comes from the DIM, the digital elevation map. The water surface elevation comes from HICRAS, which is the one that I sent to you. FFE is coming from the shape file that is already in this folder. So you already have this data. Okay. Right, let's get back here. So basically you will download the file that has your name, and you start working using the file that already assigned to you. Then you will find a bunch of mini Excel sheets. You download them all these Excel sheets. Do you guys remember F4, 3D, F3, and you will find F3, 3D elevated? What is the difference? Do you guys remember from the last lecture? This, what if 4 mean?
Archetype.
Archetype 4. And 3D means that it has duration and depth. What is the difference between this one and the one that has elevated? This one was mitigation. What kind of mitigation? Elevated components. So kind of mitigation measures that we applied for some of the buildings, and it has less damage. Okay, so this is one of the things. This one is a depth duration 3D. This an Excel sheet. You guys remember that we have 100 duration interval and 100 flood depth interval. Do you guys remember? We have 100 and 100 when we developed a 3D flood surface like this. We said that we will have depth and we will have duration, and here we will have the loss or the damage. So what we did is we said that we will have 100 value of the depths and 100 value of the flood duration. And the depths start from 0 up to 10 meter and the duration from 0 to 300 hour. And what we did, we divided the 10 into 100 interval and we divided the 300 into 100 interval. So the thing is, I put all these intervals here in this Excel sheet. So you'll find like 0, 6 hours, 12 hours, 18 hours, and all this stuff. Okay, so you'll find a lot of Excel sheets that we talked about them yesterday. Also, you will find, you guys remember this Excel sheet, building archetype 2D. 2D has the 2D functions, the 2D loss functions, and everything's related to 2D, like the relationship between flood depths and damage. It doesn't have any duration. And you also find the shapefile that you will start with, the flooded building buoyance. Okay, in this shapefile, I'm not sure if you should. Well, I think I need to change this shapefile because this shapefile is based on a specific event, like when I extract. Okay, this is the thing. The thing is, I had a hazard map, like based on Hurricane Matthew, and I have all the building in Lumberton. So what I did, I excluded all the buildings that are not flooded and only focused on the flooded building. And their number was around 25,000 buildings. And this is only based on a specific scenario, and I put them here. So why this will be wrong in our project?
Looking at different long period.
Yes, exactly. We are looking at different return period because the buildings that are flooded in 1,000 year, maybe there will be 3,000. Or the building that are flooded in 300 year or 100 year will be 2,000 or 1,800. So what I did here is based on a specific scenario. So what I'm gonna do, I'm gonna give you all the building inventory, and you will have to separate the buildings that are flooded from the buildings that are not flooded based on your scenario. So every one of you will have different number of buildings that are flooded responding to the scenario that you choose. So you will hold on this until I upload the whole building inventory, all the 20,000 building. Do you guys know how to extract the not flooded building? I showed you last time. In ArcGIS, how? You will see the building that has 0 flood depths or -999. So that means that they are not flooded. So every building that has flood depths more than 0, you select them and export them. Okay. All right, so this is most of the data that you need to initiate your project. And we start last time to look at the MATLAB code that we will be using for this project. It is this one. So let's go very quick on what we did last time. So what we did last time, we spent like, let's see how many lines so that we can read all this data, just like without doing any analysis, like 200 lines. To just read all these Excel files and shape them and put them in a format that allows us to do analysis, because there is a huge amount of data, okay? So what we did, we read the Excel file that has all the 2D loss functions for the 15 building archetype, and the same thing for the archetypes that have elevated component, like with mitigation. So we have 15 building archetype and another 15. So we have 15 loss curve and 15 loss curve. This archetypes doesn't have any mitigation, and this archetypes have a mitigation. And we already read all the parameters like the log normal parameters, the number of archetype, the number of damage states. Same thing with 3D functions. If you guys remember last time, we have 15 building archetypes, with everyone has 4 to 5 damage states, right? And each damage state has a surface, right? To get the exceedance probability. So what we want is we want a 3D function or 4D function that has a relationship between flood depths, flood duration, and the archetype and damage state. Store all this data so that when I can recall something from this function or from this matrix, I can interpolate based on what duration that this building is exposed to, what the flood depths that this building is exposed to, what archetype is this building, and what damage state that I'm looking for. So I need to know all these 4 parameters, and that's what I'm trying to do here. So that's why I'm reading all the Excel sheet. So Excel sheet number F1 3D. So it has everything about F1, and each Excel file has many sheets. So I have sheets for the damage state 0, damage state 1 up to 4. Same thing for archetype 2, 3, 4, 5. So I'm just reading all the Excel sheets. Once I'm done with the 15 archetype, I was organizing this data. How I organize this data, I just read the data, all the Excel sheets that has everything, and I put them on one 4D matrix. This 4D matrix had flood depths, flood duration, archetype number, and damage state. Damage state 1, 2, 3, 4, 5, which represent here damage state 0, 1, 2, 3. 1 represent archetype 1, 2 archetype 2, 3 archetype 3. This one, it doesn't change. It's the depths and the duration. So it will stay constant for all the archetypes. Okay, so here I'm done with all the archetypes. And so right now we're only talking about fragility. So how about losses? So how about losses? So losses, what is the difference between the loss function and the fragility function?
Loss function is function of the
And how many surfaces is in the loss and how many surfaces is in the fragility? Loss, not the same. Loss is just to one surface for the whole building. But fragility has a surface for damage state 0, surface for damage state 1, surface for damage state 2, 3, and 4. Same thing with 2D curves. Like fragility functions, fragility curves has 5 curves for each damage state, but loss curve is just one curve that you go in and get how much damage this building has. So that's why every archetype has only one, like F1 loss 3D has only one line. So F1, and then you will have, there's F1 and F1 elevated. So what is the difference? Elevated, that means this is the loss surface of the building after we elevate the water sensitive components. So you'll have 1 and another 1 elevated, 2 and 2 elevated. So right now I will try to read all the 15 building archetypes, and the archetypes that has elevated components is archetype from 1 to 4, but 5 to 15, they will still the same. There is no any mitigation that was done to these buildings. Does any one of you have any question till now? Doesn't understand what? If anything, if you have any question, just like stop me and ask me. All right, so right now I was just reading the Excel sheets. So once I read them, I want to put them in a format in MATLAB that allows me to do processing. So I have to put these in a matrix. So right now the matrix, so the fragility was a 4D matrix. The losses a 3D matrix. Why is the losses a 3D matrix? Because the fragility has flood depths, flood duration, number of archetype, and what damage state. Right now, the losses doesn't have a damage state. It's only one surface. So we are looking at flood depths and flood duration and the archetype number. So it's only 3D. So then you have here archetype 1, 2, 3, 4, 5. So we will only have one 3D matrix that has all the numbers for all the archetypes. So it's basically all right, so let's talk about this. So actually, if you divide this into like a mesh, this, So that's exactly what we did. At each value of the flood depth and flood duration, we have a number. Like we have a number here, there, and then you connect all of them together to make a surface. So you have a number at each intersection between the flood depth and flood duration. So basically, this is something like a layer. So we have a layer for archetype 1 and another layer for archetype 2, 3, 4. So you have X, Y layer for each one of the archetype. This is what is the 3D matrix at. Like you have depth, duration, and archetype. But if we are talking about the not losses, if we are talking about damage state, you have another layer for the damage state because each archetype has 5 layers for each damage state. This is very important when we do programming because programming is all about matrices, numbers that you need to find a way to store them. If you were able to store them in a way that facilitates your analysis, it will be very easy for you to get your analysis done. So right now, that's what I did. I put them in a 3D matrix so that I can recall this matrix and interpolate from this matrix. Okay, so done here. Also, you will have another one for the elevated components. So I made another matrix and I put the elevated components here. And I also, you will find some MATLAB code lines for the developing the fragilities from the log normal parameters. Okay, so we have the 3D fragility. What if I want to neglect the duration and use the 2D fragilities that we already developed? So you can use the log normal parameters from the table that I provided to you, and you will find the table also in the Excel sheet to get the sigma, to get the mean and standard deviation, mu and sigma, and use all the log normal parameters and develop the CDF for each one of the fragility surface, and then you can plot them. But in my analysis in this project, I neglected that because I already have the 3D surface of the fragility, and I know when I develop the 2D, I assume that the duration reached the max. So if you use the 3D surface at the maximum flood duration, so you will get almost the same fragilities driven from the 2D. So you don't have to do this step if you want. Okay. Do you guys understand this point? I believe I showed it to you. Maybe in one of, yeah. Yeah, like this one. So this is the 3D fragility surfaces. It's 5 or 4 surfaces, depends on the archetype. So if you cut here, here's the fragility. Like you have damage state 1, 2, 3, 4. You cut here, you still have 3, you don't have 4. But at some point, when you get to the maximum duration, the 300 hour, so you're almost having the same fragilities that comes from the 2D. So right now, we don't have to use the 2D anymore. We can interpolate from the 3D function at flood duration 300 hours. Okay, so it will give you the same thing, like this fragility. But I just showed to you if you want to get the 2D, how to do it here. And I wrote some MATLAB codes for to draw the fragility. So if we want to reactivate this, okay. If we want to rerun the plotting, the thing is it populates many. So let's see how this plot look like. Oh, undefined function. Okay.
I think you have to suppress that one.
Oh yeah. Yeah, this is not a function. I was just like making a code what I'm doing. So sometimes you need, some people like when they codes, you like to make codes so that you, if they go back to your code and want to understand again, so you know what you were doing, or if you are sending it to somebody, there's some people, I believe coding is kind of like reflective each one personality. Some people are like very organized and they make everything by the book, so they keep writing and make their codes like the room at home. So, and some people are code are very messy, so nobody can understand his code except himself. Or maybe he will not understand his code if he come back like a few days later, like he come, oh, did I write this code? Yeah, so something like this. But anyway, I'm trying to be organized as much as I can, because I always recreate this as an educational material. Like when I developed this code, I was developing it like it was developed in 2020 or 2019. I always, when I do this, I do it like I'm gonna teach it to somebody, and I don't know if I'm gonna teach it to somebody or not, but I was creating it like this, like I'm teaching myself or I'm teaching somebody. So that's when I developed this code. So you will find it a little bit organized, and that's what happened here. I was trying to write what I'm doing. I'm just plotting the 2D fragility of the loss. And if you want to write a code in something in MATLAB that just a text, you just put like this percentage mark here. Okay, so right now I just plotted the 15 fragility function. If we want to plot the surfaces, we can do the same. Like you can actually, I believe I plot them all the loss curves in the same figure here. So this is a 15 curve, each curve for a specific archetype. So we have archetype 15, 14. So all these are the 2D loss function for each archetype. So maybe it's good if you plot them and you put them in the paper. That will be great. Okay, so here I was just trying to plot the curves. If you want to plot the 3D, you can plot the 3D as well. I believe maybe it's at the end of the code or not. So, but you can plot them if you want. Okay, so right now we are done with reading all the data that we need to initiate our analysis. So I read all the 2D loss functions, all the 2D fragility, 3D loss and 3D fragility. So right now at line number 300, we can start to do the analysis. So the very thing that we need to start with the analysis is to read the shape file that has the flood depths for each building. And I'm talking about flood depths measured from the ground elevation and another one measured from the versifloor elevation. What else that we need for the buildings? So we need to know what the flood depths at each building, what else that we need to run our analysis. The archetype, right? We need what is the archetype for each building so that we know what fragility that we are going to use. So we need to extract some valuable information about these buildings. So the most valuable information about each building is just this form. What is the flood depth measured from the FFE? What is the flood depth measured from the ground elevation? And here you just name the field that is in your shape file. Don't use this field. I just like named anything. So if you name this field FFE1 or FFE2, you will have to change this to be matching the same shape file that you have. So once you extract the FFE or once you extract the flood depths measured from the ground elevation, you name the field and you put the field here. The second important piece is what is the building archetype? Because based on the building archetype, we will use all the data that we defined in the 300 lines. Okay. The third important piece is what is the building value? Okay, I can provide the building values, the losses as a percentage of the total building market value. So for example, I will end up with having this building got a flood depth of 2 meters or 1 meter, and it's archetype 1. And when I done the analysis, the losses are 20%. If you want to provide informative information, you need to multiply this 20% by the market value of the building. So if this building is 1 million, so you need to mention that this building has a 200K in losses, $200,000 in losses. So I need what is the building value for each building. And actually this information will be also provided. So if you go back here, you will find a field is called building value. So some buildings, but actually these buildings are outdated a little bit. Like this are values from like 10 or 15 years ago, which is right now, it's very high. Maybe it's doubled or tripled. But we will stick using this value because this is the only data that we have, right? Okay, so right now we are done with, we are still uploading data. We still didn't do any analysis, but right now we are shifted from uploading vulnerability data like fragility and losses. Right now we are uploading exposure data. What is the building information that I need? So here is the building shape file, and here's the information that I need about each file. This step is kind of like organizing step. Why? Because if I didn't run this step, all the analysis will be messed up. Why? Because when you extract the vertical floor elevation, the flood depths measured from the FFE and the ground elevation, you will have some building that has negative values. Because when you have the water surface elevation, and we are measuring that, we are extracting all the building that has flood depths more than 0 from the ground elevation, right? So some buildings have flood depths more than 0 from the ground elevation, but the first floor elevation is more than the water height. So you will end up with having a negative flood depths for some buildings. If the flood depth is negative, convert it to 0. So because if you have a negative value, when you go into fragility function, it might cause some problems. Let's say I can't interpolate for this now. So any flood depths is negative, I convert it. So for all the buildings from 1 to building number 2000, if flood depth is less than 0, both flood depths equal to 0. Okay, so the next is what we learned it from before, is to calculate what is the exceedance probability of each damage state. Do you guys remember the code that you written for the wind to calculate damage? So basically I'm doing the same thing. I'm interpolating from the 2D function to get what is the exceedance probability of each damage state. So I'm gonna show you in a little bit how can I do the same thing from a 3D function. But this one is based on the 2D function because I'm doing interpolation one dimension. Okay, so what I'm doing here, I'm creating a matrix that has a number of rows equal to the number of buildings in my inventory because I need to run the damage state for each building. So each row represents a building and has 5 columns. Each column has exceedance probability, like what is the probability of exceeding damage state 1? Sorry, this will be 0, 1, 2, 3, and 4. I put them from 1 to 5 because I can't, there's no vector that we can name it 0. So 1 is damage state 0. And I interpolate from the fragility function that I have, which has a depth 2D on the x-axis and has probabilities on the y-axis for archetype number I. So if this building is archetype number 4, so basically for I that has building archetype, like if you go back here, when we extracted, so building this column has F archetype, has the number of archetype. So if I am in building number 5, so basically this code will go to row number 5 and try to find out what is the building archetype for row number 5 or for building number 5. That's what I'm doing here. This is what this function is going to do. It will go building number I. For example, let's say it's building number 100 or 150. For building number 150, what is the building archetype for building number 150? So it's building archetype 4 or 5. So it will put 4 or 5 here. And then interpolate at the flood depths measured from the ground elevation. So why we didn't interpolate from the building at the first floor elevation, like flood depths measured from the first floor elevation? So what I did here, I made an if statement. If the building archetype, either archetype 1 or 3, use the ground elevation. Any other archetype, use the FFE. Why did I make this condition? You guys remember from last lecture, I wrote something here that there's something special about archetype 1 and archetype 3 because they have a crawl space foundation. So for crawl space foundation, we made that the flood depth is impactful from the ground elevation because there's some components at the ground elevation, not from the first floor elevation. But for other archetypes, The building is, the first floor elevation is almost the same as the ground elevation, and the flood depths, we accounted for the damage from the FFE, from the first floor elevation. So that's what we are trying to account for here. Building archetype 1 and 3, calculate based on the ground elevation. Building any other else, use the flood depths measured from the FFE. That's why I was asking you to calculate both, right? Okay. So actually there is some trend that we are trying to make all the building, because the building below the FFE, the damage, sorry, happened to the components below the first floor elevation is very minimal, like maybe 1%, 2%, 3% maximum. So is it worth it that we can complicate our analysis for 3% with all the uncertainties that we have in our model? So sometimes we can exclude the damage below the FFE and only consider the damage above the FFE if we want to make it less complicated. So I can delete this part and let's account that all the building will start to have damage if they got flood depths above the first floor elevation. All right. So after I calculated the exceedance probability of each damage state, do you guys remember from your code that you developed for wind? What did you do? Or you just copy paste?
No.
Okay,
We find out
What?
exactly. The question is, I was asking what step that we did after we calculating the exceedance probability of each damage state. We calculated the probability of being in each damage state. Do you guys know what is the difference between the exceedance and being in a damage state? That's a very important to understand the difference. Depths and probability. And you have 5 fragility functions, and the probability never go beyond 1. I explained this many times, but it's very important that you understand the difference between the exceedance and the probability of being in a damaged state. So let's assume these are the 4 fragility functions. So if we come at flood depths 2 meters, this is exceedance. And if you calculate from here up there, this is the exceedance. And from here to up there, this is exceedance. Like from here to here, this is the exceedance probability of damage state 1. This is damage state 2, damage state 3, damage state 4, from here to here. Okay, so this is the exceedance probability of damage state 1 from here to here. But if you exceeded damage state 1, like this has multiple things, has probability of being in damage state 1, and probability of being in damage state 2, and probability of being in damage state 3. So you have multiple probabilities here. Like, for example, I'm saying that this component has a probability of being in damage state 2 of 20%, just damage state 2. And sorry, let's say damage state 3 is 20%, and 2, 10%, and 3. So let's not complicate you. Let's write them here. This damage state 1, damage state 2, damage state 3. Let's say that 3 is 15%, 2 is 20%, and this is 30%. Okay, like this part is 15%, 20%, 35%. So if you have an exceedance of damage state, and let me write here, this is no damage. Let's write them as a 0. Damage state 0, damage state 1, damage state 2, damage state 3, damage state 4. Okay, this is very, very important. So you have a probability of being in damage state 3, 15%, and damage state 2, 20%, and damage state 1 is 35%. Let me ask you, if you have a probability of being in damage state 3, 15%, does this mean that you exceeded damage state 1 or not? If you having a probability of being in damage state 3, extensive damage, that you already exceeded damage state 1, definitely. Because You will never get to extensive damage unless you pass the slight and moderate. So if you want the exceedance of damage state 1, you need to sum damage state 1 and damage state 2 and damage state 3. But if you want to only calculate the exceedance of damage state 2, so you don't care about what happened in damage state 1, okay? Because to exceed damage state, like if damage state 3 is already exceeded, so 2 is already exceeded. So we need to include 3 and 2. But like, let's see, how about 3? So 3 will have 3 and 4, okay? Same thing here. But here for damage state 4, since it's the maximum and there is nothing below, so the exceedance of damage state 4 is the same as the probability of being in damage state 4. So this exceedance is the same as the probability of being. Do you guys understand what this means? Like if we are saying this is the exceedance, we need to know what is the probability of being in a damage state, because this is going to tell us what is the most probable damage state that the building will be at. So let's say building has probability of being in damage state 3, 15%, and damages 2, 20%, and damage state 1 like 35 or 30%. What is the most probable damage state? So it will be damage state 1, because this the one that has the maximum probability of being in a damage state. That's what I'm trying to do here. In this piece of code, I was trying to calculate the probability of being in each damage state. And then I was calculating the maximum probability of being in a damage state and assigning a damage state for each building. And this is very, very important for risk modeling. So to be a risk modeler, you need to calculate, you need to be able to know what is the exceedance probability, what is the difference between the exceedance probability and probability of being in a damage state, and how you can make inference about the damage state of the building. Like when we say, for example, that this building is a damage state 1 based on what? Based on probability. But this building, like if we say that this building is a damage state 1, this doesn't mean that it has other probabilities. No, it has other probabilities, this. But because these probabilities are lower than this, so that we assign a single damage state for this specific building. However, when we say a building is damage state 1, so we are excluding all the uncertainties that we have. Because right now we are making a deterministic decision about the building, right? We're saying this building is deterministically damage state 1. How did you know? Could be damage state 2, could be damage. So why we did this? Because we at some point need to make decisions. So you have a community that has thousands of buildings, and each building has 5 probabilities. So at some point you need to make decisions, and the decisions are deterministic. So you need to like make decision about what exactly the status of this building. We use probabilities to make these decisions. How did we use that? We have some probabilities that tells us what are the most probable damage state, and based on this, we made a deterministic decision about this building, okay? All right, so this is what this piece of code is doing. It basically tells you what is the probability of being in a damage state and what is the most probable damage state for each building. Once we are done with this analysis, I mapped my results back to the shapefile. Do you guys remember? You did this for wind, right? So you have a shapefile that has building with some flood depths. I added the values that I calculated. What is the exceedance probability of damage state 1 to 5? What is the probability of being in damage state 1 to 5? What is the damage state, the assigned damage state for the building? And what is the loss calculated for this building? And the loss is, I believe it's here in this line. So if you guys look here, when we did the for loop to calculate the exceedance probability of the damage state, we have a one line that calculates the losses. Basically, it interpolates from the 2D functions that we draw them here. It goes in this, based on each archetype, it goes at each plot depth and interpolate and get what is the amount of losses for each building. Okay, does any one of you have any problem till now? This will solve this task number 1. you did hazard model, you extracted the flood level at each building, and then you are doing vulnerability analysis and also do task 2. So what I did right now, did task 1 and task 2. We have a hazard map. We extracted the flood depths at each building. So what we did right now, hazard modeling and exposure modeling. Hazard modeling is the hazard map. Exposure modeling is to know the exposure of each building and is it exposed to flooding or not? And what is the level of exposure? What is the flood depths at each building? This is task number 1. Task number 2 is to do the vulnerability analysis, all the coding that we did until the exceedance probability of the damage state and the probability of being in a damage state and the losses. So this is task 2. So right now I'm done with task 1 and task 2. Does any one of you have any question? Everything's fine? If you have any question, just ask me. Like if you have any general question in the code, in the sequence, in anything. All right, so I will stop here today, and next time we are gonna start with task 3. Like how we do average annual loss, because we still have average annual loss and we have mitigation and we have lots of stuff. But what I want you to do is to start right now. Like to use, I'm gonna upload the whole building inventory. You will have all the data that you need. So start, run your project now because we have like 3 weeks. So we need to get it done very fast. And the last week is reserved for presentation. So you will present your work, okay? All right, so that sounds great and see you guys next time.
Go ahead.